Hi everyone, in this particular video we are going to talk about introduction to statistics and to scales of measurement. So let's quickly get to it. What is statistics? And most of the sites when you Google they'll simply say statistics is a collection of tools to gather, review, analyze and draw conclusions from data. So it's a collection of tools, first of all, to gather, review, analyze, and draw conclusions from a given data. Data can be numbers or names or anything. We'll talk about it in the second half of this video. Now, going forward, uh, obvious question is why do we need statistics? Can we do it simply by observation? Most of the times, if you notice, if you're finding 3, 4, 5. If you are looking for a number which is in the center of all these, you can simply say 3. And 3 tells you quite a lot of things about these numbers, that all the other numbers are near 3. And you can make quite a lot of observations like that. Why can't we simply make observations like this? Why do we need statistics? The first case for it is when the numbers get confusing. For example, take a look at this particular picture. This is an optical illusion, and when you look at it, you will see, you may think that it is a spiral, or it may look like some circles here and there. And this picture is made to fool your eyes. It's an optical illusion. So the truth is, they are all circles, and circles drawn with boxes. That's why it tricks our eyes into believing that it's a spiral or some other shapes. It will be different for different people. So there is a possibility for human error when we are looking at a picture or a set of data which is bigger as it gets bigger, and bringing in a mathematical structure to it, or a shapes like circle that we put in here helps us see the things which we missed without it. Without it, it looked like a spiral. Right now, we know that they are all circles by giving in mathematical structure. So it helps us reduce possibility for human error when we are looking at data. Second point is that it becomes hard when data becomes large. For example, look at this picture. Pretty normal, right? This is from Germany in 1930s, and everyone, you know what happened in Germany in 1930s. Adolf Hitler was rising to power. So everyone here are saluting Hitler. But there are too many people here. If you look closely, you have missed one interesting detail. And that detail is this one man. While everyone else is saluting Hitler, he is simply standing saying, I don't care. This is very dangerous. Human eyes missed it that day because given the way Hitler carried forward his rule, he might have been killed at that moment. But due to this big data that they were exposed to, they were not able to spot him who was not saluting Hitler. What I'm saying is when data gets bigger, it's hard to point out interesting features. For example, in a more sensible example for you, if a question if it's a questionnaire of 10 questions, and it's small, right? 10 questions are small, but what if we give it to 200 people? We have 2000 responses to deal with, and that becomes very huge to deal with our bare eyes. So that's why we need tools like statistics, which will help us crunch those numbers, that is, deal with those numbers in a better way. Third one is that it gives us ready-made tools to show our data in a more appealing way and also make inferences from it. For example, before the classes began, I gave a quick quiz on what's your name. We had some interesting questions. Do you like mathematics? And to that question, I got some interesting response. There were many people who said, I hate mathematics. Some said, I don't mind. It's just math. So they love and hate it. Or some said, I like this part of math and dislike that part of math. So they love and hate mathematics. And there are some people who say, I love it in and out. So there are three types of responses in this entire table. If you see, those who hate, those who love and hate, those who love. But if you look at this table, it's hard to make any conclusions. But instead of that, let me show you the same data in a different way. If you look at it here, it's a pie chart. It's a, this is one of the things that tools that statisticians use to show data in a more appealing way. Quickly by looking at it, I can say that majority of the class hates mathematics, and there are some, more than half of the class loves and hates, and there is least number of people who would confidently say I love mathematics. So what I'm saying is a visual representation gives us better picture. We can make quick inferences on the data we have in hand. This is not the only way to represent the data. We have many other options. For example, if you see, we can have a table here, and we can have a table like this, or we can have plots like this, which are suitable for in different contexts to make different conclusions. So I have stated three cases for statistics. Why do we need such tools? And there are many more reasons why we really need it, which I haven't touched on. You can always think through, try to find out your own reasons. And I believe, as most of you noted, it is very useful for psychologists. We'll come to that point pretty soon. Before that, let me conclude our discussion so far. What is statistics? It's a set of tools to gather, review, analyze, and draw conclusions from data. And why do we need it? It's a toolbox for psychologists and the rest of the world. It's not psychologists alone who use it. Doctors use it, pharmaceutical companies use it. Then if you look around commerce, those who are active in stock market, those who are active in stock market use it to predict the future trends. Those who are into politics use it to predict their chances to win in the next election. So it's a tool which is used by many people around the globe. Now look at this. When I say toolbox, this is the picture that comes running to our mind, right? These are all tools which are used to fix a car or build a wall or different things. But statistics is a set of tools like this, but little different from this. It exists on a paper. Set of tools which works on data. Data is numbers, names, and emotions, happy, very happy, sad, and such things. Temperature in different places. So statistics is a tool set. What is statistics? It's a tool set to work on data. And why do we need it? Because of the points we discussed earlier. When there is to make sure that we have a scientific study on things which are uncertain. So coming to the question, how is it relevant for psychologists? This is the most useful tool for the kind of data that you handle. For example, take a look at the simple definition of psychology given in Wikipedia and other sites. It simply says, psychology is a study of mind and behavior. And you know how mind and behavior is like? Today I may like cotton candy and tomorrow I may say, no, I don't like it. So our mood, decisions, everything can flip anytime. That is, there is quite a lot of uncertainty there. And including that uncertainty factor to make studies or to make conclusions, you need a scientific framework, and that scientific framework which is most suitable is statistics. Consider another example. people said there was a certain report which said Bhutan is one of the happiest countries in the world. And it is one of the happiest countries in the world because does that mean there is no one unhappy in that place? Does that mean nobody's mood changes to sadness in Bhutan? No. They have used some metrics and statistical tools to measure and find out that most of the people tend to be happy most of the time in Bhutan. They're satisfied with their government and such things. So what I'm saying is, given the uncertainty you're dealing with, this is the best part of mathematics and science that you can use to take your studies forward. And in the survey that I did in your class, you seem to agree to. Most of you said it's useful for research. And some said data analysis, it's good for data analysis. And for experiment, someone said it's an important field. When I asked you why do you want to learn statistics, someone said I love statistics and I love psychology. I would like to know how they both go together. Now, before I go to the next slide, let me show you the same information in a different way in the pie chart. So, this is the advantage of statistics. It helps the psychologists take their research forward and gives them a scientific framework for their research. Going forward, there are two kinds of statistics. One is descriptive, where we try to describe the data set in our hand, and another is inferential, where we try to draw conclusion from the data which we described earlier. Something like central tendency and everything belongs to descriptive statistics. And then if you look at the next picture, it is talking about poll predictions in US. What they do is they can't take opinion from everyone who votes. They'll select a random group of citizens and take their opinion. And based on their opinion and using statistical tools, they'll be making predictions on who may win or how to better my poll campaign. So they are making predictions or drawing conclusions from the data that they gathered. And even from the step of gathering data to the step of drawing conclusions from it, they are using statistical tools. So this is another thing about statistics that I wanted to point out. Now, talk about tools. Why do we need so many different tools? We are going to talk about different tools now, especially when it comes to gathering data. I'm talking about scales of measurement. There are we are going to talk about different kinds of data to gather when we gather information, and we have classified them into different kinds because based on the type of data, we know what statistical tool can be applied on it. So when we are defining or when we are setting a questionnaire, in the questionnaire we will know the kind of response we get and what kind of study can be done on the response that we get for that particular question. So that's called scales of measurement in statistics, and let's get to it. The first kind is nominal scale, and so I asked you for your names during the session, and most of the responses I got are Ren, Maya, Rich, Naba, Iba, and Christine. So what I'm saying is there are different names, and then another question I can possibly ask is, what is your gender? You may say male, female. So we can differentiate between them. Male and female are two distinct things. We can differentiate. Ren and Rin are two different people. We can differentiate, but they cannot have a meaningful association with numbers. Thing is, what if I say Ren is 20 and Rin is 12? That cannot be a meaningful association. We can assign a number, but that cannot be a meaningful association where we say Ren is 20 because of a certain reason. We can't find a reason to assign 20 to the name Ren. Such type of data are called nominal data. And another thing is they cannot be ordered. I cannot say Ren is greater than Ren because They're two different people. They have different skills, different abilities. And by knowing their name, I cannot do any such comparison. So that's the thing with nominal data. They can't be compared. They can't be compared greater than or equal. They can't be ordered. But we can check whether, suppose one person came at first and second person came the second time. We can check whether it's the same person who came. So we can check if they are equal or not equal, but not greater than, order them greater than or less than, or give them a particular structure like that. Only measure of central tendency possible is mode. Mean and median cannot be used. Now, the second kind is ordinal scale. And I asked you your like for mathematics. Some said, I love mathematics. Some said, I hate mathematics. Some said, I love and hate mathematics. Right now, my mission here is to make you fall in love with mathematics. So what I would do is, who should I give most attention to? The people who will get most attention to from me are those who hate, because I need to convince them that mathematics is cool. And then those who love and hate, and then those who love mathematics. So that I can, by giving them more focus, I hope to bring them to love mathematics. So here, if you notice, these are all labels. There may not be a number associated to it, but there is an ordering for the labels that we have chosen. Then if I ask, are you guilty or not guilty? For example, you are conducting an experiment on prisoners who are found guilty and sentenced for jail. Your experiment is about whether they accept the judgment, whether they feel they are guilty despite court ruling that they are guilty. So there you'll have to ask each prisoner, are you guilty or not guilty? Suppose your aim is in proving that most of the prisoners who are sent to prison are guilty. Then you may give a higher preference for those who say we are guilty and those who say they are not guilty. What I'm saying is there is a particular order. This is the ordinal scale, where it allows us to rank the data in a particular order. But it doesn't allow us to measure the amount at which they are different. For example, how much does Cody and Iba said, I hate mathematics. But how much does Cody hate mathematics more than Iba? I can't quantify it. I can't give you a number about it. So that's one of the things, one of the downsides of ordinal scale. So we have much more mathematical operations than nominal scale here, greater than, less than, equal. Most insightful tendency here is median. Nominal scale had only mode, but here we have median and mode. But mean will not work here. So nominal scale had only labels. They were not comparable except to check if they are equal. Ordinal scale, they have a rank, but we don't know the degree at which they differ. To fix this issue, you have something called interval scale. Questions like, what is the temperature in the town? Here, suppose New Delhi is 28 degrees Celsius and Shillong is 24 degrees Celsius. You can clearly say that Shillong is 4 degrees colder than New Delhi, or you can say that New Delhi is 4 degrees hotter than Shillong. So another question possibly is, what is the date of birth or year of birth? One of my friends was born in 1994 and another one of my friend was born in 2000. So I can clearly say that one person is 6 years elder than, or 6 years younger than the other person. So we are able to quantify the degree of comparison between them. That was unlike ordinal scale, where we were not allowed to quantify the differences. So allows us to allows a rank order by which data can be sorted. First of all, that's just like ordinal scale. Brings in a degree of comparison. For example, we know that World War I finished in 1918, World War II finished in 1939, and it is 21 years after World War II began 21 years after World War I. They're able to bring in a degree of comparison unlike ordinal scale. And most meaningful, insightful tendency is mean. We can start using mean now on interval scale data. Mean, median, and mode can also be used. So mean, median, and mode are useful on interval scale, and it lacks an absolute zero. That's a small problem. For example, if you say 0 degrees Celsius in 0 degree in Celsius, it may be not 0 degree in some other measurements. What I'm saying is it lacks an absolute zero. It depends on the scale of measurement which is used. For example, right now we are saying we are in 2020 AD because we had fixed a time 0 AD in past. That fixed time is not, it was fixed by us for our convenience. It is not absolute. It, instead of 0 AD was fixed based on a certain event. So it lacks an absolute zero. Ratio scale fixes that problem. Questions like what's your weight, what's your height has an absolute zero. It cannot go negative. It has an absolute zero, and it allows a ranking just like ordinal and nominal scale, and brings a degree of comparison just like the other two, just like interval scale, and it has a definite zero. So the most insightful central tendency is mean, but median and mode can also be used. To summarize the entire discussion, we know that can be labeled, all of them can be labeled, and there can be an order for the values. Order of values is known only for ordinal, interval, and ratio type. Can quantify the difference between each value can be done only for interval and ratio, not nominal and ordinal. But only ratio scale has a true zero. Another way to look at it is central tendencies. Only possible central tendency on nominal scale is mode, and you can use median as well on ordinal scale, while interval and ratio scale you can use all three possible central tendencies. That is mainly because we can give a meaningful assignment of numbers to these two scales. If you noticed, ratio scale had all text. Does that mean we should use it when we frame a questionnaire for all the questions? No, we can't. When you ask a person's name, there is no way you can expect a response in ratio scale. It has to be in nominal scale because names are not comparable. So ratio scale may be the most flexible when it comes to future mathematical uh, calculations and taking the calculations forward, but there are times when you have to use all four types of scales according to the situation. With that small note, I'll conclude this video. In the next video, we'll be talking about different measures of central tendencies, in particular, mathematical measures of central tendencies.